is a derivative of tangent. Derivative of tangent is secant squared x. Okay, secant squared x. So derivative of tan is secant squared x. Okay, we're going to prove that here in a second of how that comes about. So we did not. We started on 7.2, and this is 7.3. Yes, that's right. Okay, so this is Unit 2, Part 2. Okay, because we're still doing derivatives, so we're still calling it Unit 2, but this is 7.3. Like we did 7.2 the Thursday before break. Now it's a sine and cosine only. Now we're adding the rest of the trig functions. Okay, so we're all familiar with tangent is sine over cosine, correct? Okay, that's what tangent is a trig function. So if I take the derivative of sine over cosine, what would I have to do? I have to do the quotient rule. So that's what the proof comes from. Is everybody okay if I go, or you want to write this down still? One sec. Okay, no problem. One over cosine. So that's 1 over cosine squared is what that means. But we can just write it secant squared. Okay? I'm going to go through the proofs next page. Okay? Oh, should you write it down? You don't have to. If you want to, you can. Okay? So here's the proof. Okay? So I'm going to go through it with you, so just stay with me. Okay? So remember, it's low. It's low. So it's sine over cosine. Okay? It's low d high over high d low. So low cosine x, derivative of sine x. What's derivative of sine x? Cos x. So that's why we have two cos x's now. Make sense? High d low. Okay? Derivative of cosine is what? Negative sine. What's a negative times a negative? Why did I tell you this is awesome? Why do we like that? Because it's 1, and that's the proof, and that's it. 1 over cosine squared x. 1 over cosine squared is secant. Okay? Any cosine at the bottom we recognize as secant. Okay? So that's why it's not that bad. That's why I want to show it to you, because it gives you that identity on the top. Okay? This is kind of the guy that you kind of want to hope for. That really helps you because it becomes a 1. 1s are easy to work with. Okay? Any questions with that? Okay, so that's where derivative of tan comes from. So derivative of tangent is secant squared x. Okay? Yeah, we have cotangent. That's actually, I think, the next one. Oh, not next. Okay, derivative of cosecant. Okay, derivative of cosecant, which is 1 over sine, is negative cosecant cotangent. Okay, and I'll show you the proof for that here in a second. I think it's right there, but I'll go forward with it. That just means derivative with respect to x. Remember, when we do that to both sides, that just hits the x. But if we were doing dy dx, that's when we hit the y. Yeah. Okay. All right. So because the dy dx is over here, because we hit the y. Okay. So this is what happens. We're going to write cosecant as 1 over sine, because that's what it is. 1 over sine, we'll write it as sine to the negative 1. Okay. Is everybody okay with that? So then derivative of that, we drop the negative 1. Okay, then we get the negative 2 up here, and then we take the derivative on the inside. Derivative of sine is cos. That's why it's right there. Okay, and then what they do here is they break up, they put this on top. So what they do is they write it like this. This is kind of the tricky part. But then they take out one of the 1 over sines, because we don't have anything that's, I guess the best way to say is, we could write it we could write it 1 over, I'm trying to think about it. We could write it cosecant squared, cosine, but this is the simpler way of writing it. But anyway, so what they did is they pulled one of the sine x's out. Okay, so then what you have is you have a negative sine, you have a cotangent, and a cosecant. They just put them in different order, which is fine, but that's where negative cosecant cotangent comes from. Okay. Hardcore hiccups. All right. Okay, so then here's the list, and I'll pause the video. Here's the list of all the trigonomic functions. If you want to write them down yourself, you can. If you want to just highlight them on your sheet that I gave you, you can do that as well. But this is the derivatives of trigonomic functions. All right, so example 1. So we got 1 over 1 plus tan x. So guys, just look at this real quick. What would be the easiest way to try to differentiate that?
Make it -1.
Yeah, make it -1, exactly. So 1 plus tan x to the -1. That'd be the easiest way to do it. Okay, now that we've done that, we're just going to go drop the -1, rewrite 1 plus tan x. Derivative of the inside is what? Well, what is the derivative of? Just the tan x. What's derivative of tangent? Secant squared x. Okay.
Wait, do you need the -2?
Yes. Thank you. Okay, and it's a -2 there now. So then how would you write this to be completely done? Good. Over. Yep, and that's it. So that's your dy dx. Okay, so like I said, it's more about organization. It's not, I'm not going to say it's super hard. It's more about organization. Any questions on that one? That's a basic one, but if you have questions, let's get it done now. Good? Okay. All right, let's move it up here. Okay, so 2. Differentiate that one. It's a little bit harder. Okay, it may help you to write it like so. Okay, it may help you to write it like that. Okay, I'm going to pause for a second. I'm going to let you guys try it the best you can and see where you get stuck. This one is a little difficult. It is like one on your warm-up, though. All right, so the first thing I'm going to do is drop the 3. So it's going to give you 6, okay, cosecant 3x squared squared. Okay, now I have to do the derivative of cosecant, which is what? Right, and you write the same, whatever you have in there, you keep it. Okay, you don't make it an x. I'm doing it. Okay, and what's the last hook of the chain? 6x. Right. Okay, so now what you do is, we can go ahead and put the 6 and the 6x and the negative all together. That's -36x. Okay, I have a cosecant squared and a cosecant. So that's a cosecant cubed. I can do that because they're the same inside. So I'll have cosecant cubed 3x squared. And then I have the cotangent. That's your answer. This is your derivative, or y prime.
Can you explain
Okay, so we had a cube here, right? And I dropped that down, gave me a 6. It left this one as a 2. Okay, when I took the derivative of cosecant, I got another cosecant out here. So cosecant and cosecant makes a 3. I had 2 and a 1. Okay? And then what I did, though, just so you know where this came from 6, -1, and 6x. I can multiply all those, and that gave me -36. Okay? Again, cosecant squared, cosecant 1 is cosecant 3, and then the cotangent's the cotangent. Okay? Questions or concerns with that? Anything else? Clarification? Good? All right. All right. So this one we have to use implicit. Okay, so now we're going to do the other step of the stuff we already know how to do. Implicit. Okay, do you want to try it or do you want me to do it? You want to give it a roll? So you have tan y equals x squared. So you want to take dy dx, or derivative of both sides. So I'll let you try it. That's fine. So this, like I said, this is the one with the y. We're still going to take the derivative of that normally. It's going to be secant squared y. We have to put a dy dx next to it. That's the part we're solving for, right? We're solving for dy dx. That's the implicit differentiation. The right side is 2x. Okay, well, how do I break this off now? I divide it. Good. So dy dx, is what we're trying to get, is 2x over secant squared y. Does anybody see something that's kind of weird or something that maybe I don't need? What do we know about secant? Secant is what? It's inverse of cos, but secant's on the bottom. Exactly. So this thing can be written as 2x cos squared y. You don't need, they'd both be right, sure. But the cosine x, like when we get plugging in radians and stuff like that, it's easier to do with the cos. So just to let you know what I did there, secant is 1 over cosine. If I have something that's 1 over or in the bottom, it comes to the top. So it just becomes the top on cosine. These are the same thing. Right? Okay, any questions on that? All right, we got kind of the tough one now. This is the tough one. We're going to do the tough one, yeah. All right. So we have to use a little bit of identities here, so be prepared for that. So I'll just go through it with you to kind of get you started. So we know the definition of a slope of a tangent line. That just means derivative. So don't be thrown off by that lingo. We should know that by now. So it says find the slope of the tangent line when sine of x is 1 over pi. So it gives you a value for sine of x. Now, when I want to tell you when it does that kind of stuff, what do you want to try to get your stuff into then? Sine x's. Because then whenever you have a sine x, you put what in? 1 over pi. Does that make sense? So that's what we're looking for a lot of times. Now, if I have let's say I have a cosecant, is that still good? Yeah, because cosecant's still in respect to sine, right? It's 1 over sine. So let's point this out. A couple notes here. So we know that sine of x equals 1 over pi. Who knows what does cosecant x equal? Pi. Very good. Okay, that relationship's important to understand. Okay, so anywhere we have a cosecant or anywhere we have a sine, we can replace them with those two values. Okay. The interval, we won't worry about that as much right now, but what that means is between 0 and pi over 2. So like on our unit circle, where it's talking about this section. That's all it means. Okay. Anything else before we get started? So I'm just going to take the derivative. That's all I'm going to do first. Okay, so let's take the derivative. So what's the derivative of tan? We did that. Is it negative or positive? Positive. Okay. Secant squared cosecant x. And what's the derivative of cosecant? Negative cosecant cotangent. Okay? Now, do we have some cosecants? We do. Okay, I can put pi's in for the cosecant spots. So I have, and I also have, we'll do that in a second. Okay, so we have secant squared, cosecant equals pi to us.
What's the sign after minus cosecant? Like if it's minus.
Minus cosecant x cotangent x.
Are we subtracting it or?
It's multiplied, sorry. Yeah. Okay, and that's going to be minus pi because it's negative cosecant. And I'll leave the cotangent for right now, but we'll talk about how we can address that. Okay, that's when we're going to have to work for a little bit. All right, so let's stop right here. Do we have any questions from this point? Where I got the pi's, where the cosecants went, any of those questions there? Okay, so secant squared is what? It's 1 over cosine, right? Secant squared? Yeah, well, not the derivative, sorry. It's 1 over cosine, okay? What is cosine at pi? So over here. Negative 1. What's negative 1 squared? 1. So this equals 1. Okay, so in our unit circle, remember that that's 0, pi over 2, pi, 3 pi over 2, and then back to 2 pi, right? Cosine is your x values. So right now, this is the same thing as 1 over cosine of pi squared. It's the same thing as secant squared. Okay, so if I come over here to pi, that x value is negative 1. Negative 1 squared is 1, so this essentially just goes away. I'm plugging pi in. Yeah, yes. It being cosine tells me the x value. Does that make sense? Okay. It should be on the trig identity. Does it? Okay, then that part isn't, I guess. But you'll probably have something like that. So just a second, let me elaborate on what Abby said. The reason we're using the x values is because secant and cosine are x trigonomic functions. Okay, cosine and secant go with x. Sine and cosecant go with y. Okay, and then tangent is a combination of the two. Does that make sense? Okay, who else had a question?
How is the pi is part of that term? That's how it goes down.
Pi. This? Well, because remember, when you write it like this, that's the same thing as writing it like this. That's just what we talked about. So I was just trying to show you why the negative 1 became a 1. Because negative 1 squared is 1. Okay, anything else before we start attacking the cotangent, which is the harder part? Oh, dang it. Okay, so what do we know? Let's get to where we at now. We are at 1. We're at a pretty simple spot, actually. We're at negative pi cotan x. That's where we're at right now. Everybody okay with that? So what do we know about cotangent? What is cotangent? It's cos over sine, right? But we know what sine is, but we don't know what cosine is. Right? Okay? So what I'm going to do is I want to figure out cos in terms of sine. Close. We're going to use an identity. So let's do this really quickly on the next page. So I'll come back to this. Okay? So I want to figure out how I can get cos in terms of sine. So we have a trig identity that relates the two to the value. That one. Could you right now solve for cos and have sine on one side? Yes, and that's all we're going to do. We're going to minus the sine squared x, cos squared x, equals 1 minus sine squared x. So what do I do now? I square root, because I want it to be cos x. So this is what represents cosine. We can replace that. So what I'm saying to you is that what is sine to us? 1 over pi. Okay, so this is what we're going to have. Is everybody okay with that? That's kind of a tricky thing, yep?
Yeah, but why did you say the derivative of cosine? Or do you not need derivative?
The cotangent came from the derivative.
Okay, never mind.
Yeah? Okay, so what's going to happen now is I'm going to replace that cos x with what we just had. Sure. Actually, let me rewrite this. I'll stay on this page. So we are at negative pi cos x sine x. That's where we're at. Okay. And what I'm going to do is we're going to write 1 minus sine squared x all over sine x. Right, like that, so it's all in sines. I do have a pi in front. I'll keep that there, I guess. Okay, so what can we do now? So put in 1 over pi. So let's do the top first. 1 minus, since it's sine squared, it's 1 squared over pi squared.
Wait, what?
So we put 1 over pi here. It's squared, so you square the top and the bottom. You're just squaring what it would be. Say it one more time. Yeah, sure. Okay. And now, can I combine these? Right, common denominator, so I'm going to go like this. Pi squared, I'm making the 1 pi squared over pi squared. Because that's equivalent to the 1. And now I can combine these two. See, I made this pi squared over pi squared to get a common denominator. Now I can put this together. He's still there. He's just chilling, yeah. He's just out here. It's a negative pi too. What's that? Can you just do that, Abby? Or who said that? Yeah, you can just do that because all I'm doing is get a common denominator. I didn't change my values because pi squared over pi squared equals 1, right? So we haven't changed a number or anything. Okay, so now what we have is this. We have pi squared minus 1 over pi squared all over the, the 1 over pi. And we still have this guy here too. Sorry. Go ahead, Abby. What?
Is the pi from the bottom the one that's dividing?
The pi from the bottom. This one?
Oh, it's still there? That's on the bottom?
Yeah.
And we just change the pi squared out to be 1.
Yeah. Okay, so quickly, this cancels, and we'll finish. Apparently. Yeah, we'll pause it. So, back from the fire drill. First thing is, yes, these pi's don't cancel. That's wrong, so sorry about that. It actually makes it a pi squared. So I'm just going to put this up here and make it a pi squared right now, and then we'll cancel off the rest in a second. So what that puts us at, negative pi squared. I'm going to write this like I was just talking about. Since that's a fraction, I can write it like this. Okay, we can square root of pi squared on the bottom there to be 1 over pi. And then I cancel these. Okay, so the actual answer, I know I'm running out of room, but the answer, we're done. Y prime, okay, is, the slope, not y prime, we already did the prime. So the slope is negative pi square root pi squared minus 1. That is a slope because why? Those aren't variables, right? Pi is a number. So this is a slope. This is a numbered slope. You can get a value if you put that in your calculator. Okay, so I was looking all over the place. I'll leave it here. Stop the video and we can talk about it if you'd like. But that's all for this lesson.